Hello. In this video, we will explain link state algorithm programming exercise in NetSim academic version. NetSim programming lab has been designed to provide hands-on network programming skills to students. The labs come with a GUI where students can first run the experiment in sample mode and visualize its working. And subsequently, they can write their own code and link it to NetSim. Programs can be written in C and the executable can be linked to NetSim for visualization. Link state algorithm is present in shortest path programming exercise. The objective of this exercise is to find the shortest path between source router and destination router using Dijkstra's algorithm. As explained earlier, there are two modes of operation in NetSim. In sample mode, shortest path algorithm code is already written in the backend and NetSim will execute that code. In user mode, NetSim will execute the algorithm code written by the user. In our example, we select link state and set the number of routers as 5 with source router as 1 and destination router as 5. Now the user needs to set the distance between routers. All you need to do is click on two routers and set the distance between them. We set some example distance between the routers as follows: R1 to R2 as 10, R2 to R3 as 5, R3 to R4 as 12, R4 to R5 as 8, R5 to R1 as 50, R2 to R5 as 20, and R3 to R5 as 2. Now we click on run. As you can see, link state algorithm code already written in the backend will be executed to find the shortest distance between source router 1 and destination router 5. Here, amongst multiple paths, the path displayed in green color indicates the shortest path between router 1 and router 5. If you can calculate the shortest path between router 1 and router 5, you would notice that it is R1 to R2 to R3 to R5, and the value is 10 plus 5 plus 2, which equals 17. This is sample mode. For user mode, the user needs to link his own source code in exe or jar format. For that, the user first needs to understand the concept of shortest path and the code flow by using the link provided in the help section, concept, algorithm, pseudocode and flowchart. For easy implementation, interface source code is already provided where user can write his own code in the specified area, write your own code here and link it to NetSim to run. To run in user mode, the user needs to link his or her exe or jar file. The exe file can be created using Microsoft Visual Studio 2010, Dev C++ or GCC. We will explain how to build an exe file of C code using Microsoft Visual Studio 2010. Open Visual Studio 2010, go to File, New, Project, select Win32 under Visual C++, then select Win32 console application and enter any file name, let's say shortest path, in the name field and click OK. Then click Next. Select console application and enable empty project. Click Finish. Then in Solution Explorer, right click on source files, add new item. Select Visual C++, then select C++ file.cpp and enter the file name. Make sure the file name ends with .c as we will write C codes in the file. Copy all the contents of interface code and paste it inside this file. Now the user needs to implement the algorithm code inside the function fn Dijkstra. Write this code per the flowchart and pseudocode. In our case, we are copy pasting an implementation code we wrote. A copy of our working codes are provided along with the CD of NetSim. Then go to the build menu and click on build solution. It shows build 1 succeeded. The exe file is now created in the default path My Documents Visual Studio 2010 Projects Shortest Path Debug Shortest Path.exe. Now run the shortest path programming exercise in user mode. Here NetSim asks to attach the exe or jar file. We browse to the path of exe and attach the shortest path.exe and click OK. Now we follow the same procedure that was used to run shortest path in sample mode. And you can see the same output as before, except that in this case NetSim ran with the user's exe. Hope you enjoyed this video on how the user can use NetSim programming exercise to understand and implement Dijkstra's shortest path algorithm. Thank you.